How's it going, ladies and gentlemen? Mr. Donnie here. Once again, this time we're going to take a look at phase changes and energy. Identify the different phase changes, including sublimation and deposition. Good examples would be like carbon dioxide and iodide. It doesn't do that. Describe the energy changes as endothermic or exothermic, as well as what's going on in terms of entropy. And describe what is happening in terms of attractive force strength during phase changes. All right, so here we got a little diagram. Let's fill it in. All right, so solids, particle diagram, those things are packed really close together. Liquids, they start spreading out. They take the shape of their container, but they got a definite volume. And gases spread out. They have no definite shape, no definite volume. So things we're probably familiar with. Going from a solid to a liquid, we call that melting, right? From liquid to a gas, we call that vaporization. Or sometimes you might hear it called as boiling, right? You're going to boil all that. Ultimately, you're vaporizing. You're turning it into a vapor. The potentially new one, from a solid to a gas, we call sublimation. Now, a substance that you may have heard of that does sublimation would be called dry ice. Why is it called dry ice? Because it skips the liquid phase. It doesn't get wet. But really, all dry ice is solid carbon dioxide. And what it does is it skips the liquid phase and it goes straight into the gas phase. It does sublimation. All right, so now let's go in the opposite direction as we go from gas to liquid to solid. All right, well, gas to liquid, we call that condensation because it is condensing to become a liquid. Those particles start off real spread out, but then they condense and get really close together. And from a liquid to a solid, we call that freezing. You put some liquid water in a tray and put it in the freezer. It freezes it. All right, and then going from gas straight to a solid, we call deposition. And usually my thought of like examples would be like anytime you see like frost on a window where it was like, where did that come from? Or frost on the grass. It's like, I didn't see a liquid at all. And it was just all of a sudden there's solid on the window pane. How did that happen? Well, the water vapor in the air turned directly into a solid and it went through deposition. Now, as we go from a solid to liquid to gas, as we go left to right in this diagram, these are all endothermic processes, meaning that the heat, the therms, are going to end up inside of our stuff, endo. If you want to melt some ice, you got to give it heat. That ice has to absorb that heat, and that makes it endothermic. And what happens in terms of entropy is as we go from solid, liquid to gas, the entropy increases. It becomes messier. All right, so if we take a look at going in the opposite direction, most of this stuff, probably not going to blow your mind, is the opposite. Going from a gas to a liquid to a solid, the entropy goes down. All right, and now the opposite term of endothermic is exothermic. You may have seen exo with like exoskeleton. And all an exoskeleton is it's on the outside. Exo means outside. So the heat, the therms are going to the outside, exo. If you want the liquid to freeze, you got to remove the heat from the liquid so it turns into a solid. All right, attractive forces, which I may abbreviate as AF, sometimes they're referred to as intermolecular attractive forces. And all that means is it's in between molecules, intermolecular. And they will hold the particles together in like the solid state, right? Or the liquid state. It's what's holding them close together. The closer the particles are, the stronger the attractive forces are going to be. So as a substance changes phase, the attractive force strength will also change. So like what's going on with water molecules is, hey, there's a generally a negative region of this water molecule, and there's a slightly positive region on the other end of the water molecule, and we know that opposites attract. So between those two molecules, there's going to be this like pull between them. All right, so let's take a look at attractive forces. As we go from solid, liquid to gas, what's happening is the attractive force strength is decreasing. Right, as we go solid, liquid to gas, those particles are getting further apart, so the attractive force strength is going to go down. But what's going to happen is the potential energy is going to go up. It's like you're separating magnets, right? As you separate those magnets, there's less attraction between them, but you stored a bunch of energy. You turned it into potential energy, because if they come together, thwap, they'll release all. So if we go from gas, liquid to solid in the opposite direction, the opposite is true. As they get closer together, the attractive force strength is going to go up, and that potential energy is going to be lost. All right. So phase changes in energy. Can you identify the different phases? Phase changes, including sublimation and deposition. Can you describe the energy changes as being endothermic or exothermic, as well as what's going on in terms of entropy changes? And can you describe what is happening in terms of attractive forces during these phase changes? I hope so. I hope you found this helpful. See you in class. Goodbye.